Great. Thank you so much for coming to this session. I appreciate you spending 1 hour with me in this room talking about Visual Studio Code. So my name is Rong Lu, and I am a program manager on the Visual C++ team. Realize my mic is not on. No, it's good. My name is Rong Lu, and I am a program manager on the Visual C++ team at Microsoft. I've been at Microsoft for over 10 years, the last 6 years on the C++ team, and most recently I started working on Visual Studio Code experience for C++ for the past 6 months or so. So today we're really excited to be here to share with you what we have got in Visual Studio Code for C++ developers. Oh, first of all, before we get started, if you haven't already, take our developer survey, and you have a chance to win an Xbox One by end of the conference. So we're gonna reveal who the winner is on Friday. So make sure you get that URL akms/CppCon. So we do that every year. We collect developer feedback that really helps us shape the future of the product. So definitely take that survey, even if you don't care about an Xbox One. And before we are going to start talking about what this talk is going to be about, this is not the talk on MSVC and VS 2017. Because we have another talk that's going on right now at the same time, that is about MSVC, Microsoft Visual C++ compiler, libraries, and Visual Studio 2017. So that if that is the content you're looking for, should definitely either check out that room or watch the video online afterwards. But I just want to make sure you are in the right room and looking forward to talk about VS Code. So this is what we are going to talk about in this session. So we're going to start off with a quick introduction to Visual Studio Code, what the product is about. And I'm going to spend most of the time doing demos, actually in the tool. And then we will have a few summary slides. So for the demo part, actually before I get into that, can I get a quick show of hands? How many people have heard of VS Code product? Everyone? Wonderful. How many of you have used it? Almost everyone, maybe 85%. How many of you have been using it on a daily basis? Couple? 6, 7, 8. Okay, thank you, great. So since most of you have heard of the product and the majority have used it, I'm gonna go over the easy part fairly quickly. So we're gonna start off with something really simple. So I wanna do a 20-minute challenge to myself on stage, and my team members think I'm crazy that I wanna do that on stage, but I actually wanna build something from scratch, like with zero code to start with. And then we're gonna get into how we build the code and debug the code on stage, or within 20 minutes. So hopefully I'll be successful. But then we're gonna move into trying out a more complex C++ program in VS Code. We're gonna talk more about IntelliSense features and how you build and debug with more advanced features. And then last but not least, I'm gonna show a few VS Code features, how you can make VS Code your editor. There are tons of things you can customize in Visual Studio Code to make that your editor. Does that sound good to everyone, what we're going to cover today? All right, cool. All right, so quick introduction, because you guys already heard or have used it. So this is Visual Studio, which is a really great IDE on Windows. It is meant to be a fully featured IDE, which has got lots of features in it. It helps you to target multiple platforms. It's got rich editing experience, advanced debugging. It's also got like testing, advanced diagnostics, packaging, tons of stuff in that. And that's what Visual Studio is meant to be. Visual Studio Code, on the other hand, was invented with a different goal in mind. It's meant to be a lightweight code editor. That's why we added code to his name, and we completely changed the color of the logo, just not to be confused with Visual Studio. So it's meant to be a lightweight but powerful code editor. More good news, it's completely free. It's open source on GitHub, and it runs everywhere. By everywhere, really mean it. It runs on Windows, Linux, and Mac. It has got built-in support for JavaScript, TypeScript, and Node.js, but it does support many more languages via extensions. So we at Microsoft, we provide the C++ and the C# extensions, and there's the community out there that's providing much more language support as well. VS Code is completely extensible and customizable, which you'll see in some of the demos later on. Last but not least, it also got Git integration, so you can pretty much do everything from within the Visual Studio Code IDE. So let's talk a little bit about the VS Code C++ extension that we provide. Basically enables C++ IntelliSense code browsing, code formatting, and debugging functionalities. And since it was shipped a year and a half ago, we have got over 3 million downloads. So we're really proud of that, and we are keeping updating this extension on a monthly basis. So you're gonna see a lot of updates. And today, actually, I'm gonna show the absolute latest features that I have installed on my machine that's going out this week. So there's definitely something you haven't seen before that I'm gonna show you today. And of course, it runs cross-platform. We do support all the 3 platforms that VS Code supports. That's why I have brought you 2 different machines today. Here's Mac and Windows machine. I'm going to do demos on both machines. Just so you know, I'm not lying to you that we support cross-platform. So you're going to see the experiences on different machines. All right, let's get into my 20-minute challenge. Let me switch over to my Mac machine. Awesome. All right, this does not count. Let me just show you real quick. For people who haven't used this tool before, real quick, how the simple layout in the VS Code UI, really that you're working with a couple of tabs on the left side. This is where you see all your files. It's like Explorer, and then this is your search, Git, source code, control integration right here. This is the debug menu, which we're going to use later on when we debug. This is where you see extensions. I don't have this machine connected, so I don't see this list, but otherwise you're going to see a full list of extensions on the marketplace that you can download and install right here. And on this machine, I only have the C++ extension installed. And that's everything I'm going to show you is either features in VS Code itself or comes with the C++ extension. So that's the only extension you're going to need. And up here, a few quick menus over here. So you have File, Edit, Selection View, Go, that's all for navigation. And then you got Debug, that's for debugging stuff. Tasks is where you're going to run your build tasks. We're going to see that later. And then you got Window and Help, and that's all. It's really, really simple layout for it to get started, so it's not too overwhelming. All right, now, if anyone want to count the time, I'm going to start my 20-minute. All right, I'm going to do this here. Okay, first of all, it is going to be from scratch for sure. So what I'm going to do is new folder here, and call it CppCon. I want to open a folder as opposed to open a single file, and there's a reason why I'm doing that. If you open a folder, you're going to get better IntelliSense experience. For single file, we have zero knowledge of your code, therefore we're never able to provide anything. But if you have a folder, which I'm going to open here, we are going to do some magic behind the scenes. I'm going to show you what the magic is going to be after I'm done with the challenge, so that does not count. I'm going to do a new CPP file. I'm going to do a simple calculator. So I'm going to do it like a console-based app, so I know I'm going to need cout, cin. So right away, I'm going to type in include. You see I get some IntelliSense help right here. And I'm going to do main. And start writing my code. So I'm going to do std : You see I get the autocomplete list right here if I type in cout. You see the quick info tooltip right there. So there's definitely some magic we're doing behind the scene for supporting that. So I'm just gonna type here.
Is that real intelligence?
It is real IntelliSense. It is real IntelliSense. I'm going to show you how we do that later on when this is done. Hold on that thought. Okay, so since I'm going to do this a couple of times, I'm just going to do a using namespace. And here, you see, once I do that, I still get IntelliSense. Okay, save, and now I'm gonna do my calculator. And I will have one method, one function here that's public, and I'm gonna have it return integer, and I'm gonna pass in two integers and a char as the operator. And now I'm gonna implement this function, which goes calculator, and I get IntelliSense here as well. As I type, I get function, and I'm gonna do y. See how hard it is to type on stage. That's why it's a challenge. Okay, so I'm gonna cheat a little bit here. If you let me, I'm gonna copy over. Well, don't laugh. There's a reason I'm doing this, okay? Okay, pasting the code. Looks fine, but the formatting is kind of weird. So I'm gonna do right-click and say Format Selection. And it's formatted. We do support clan format in VS Code. Don't laugh.
You got a thumbs up over there.
Okay, good. All right, now I'm gonna just call this function in my main method and do please enter number 1 and operator number 2. Like that. I'm gonna take user input. Before I do that, I'm gonna need a few variables. And I need a char as my operator to see. And a new calculate across and give that value to result. And you see I got IntelliSense again here. And as you can see, as I type, I get the parameter hints as well. So it tells me what to input there. So it's x. As I move on to the next argument, it's going to highlight the different argument in the argument list. So it's really handy here. And last, I'll put my result. Yes. All right. Wait, I need a result. And. Okay, let's do the format document. So everything I typed in is auto-formatted. Nice. All right, I think I'm done. Did I miss anything? Let's try. How about let's try? So I did a bunch of typing. Now, if I'm good with the code, let's try build this code. So Visual Studio Code does not come with a compiler, which means you have the freedom to choose whatever compiler you want to compile with. So in this particular case, I'm on a Mac machine, so I'm going to use GCC to compile this code. I already have that installed. But how are we going to tell VS Code how to compile this code using GCC? Now let's do that. I'm coming from a Visual Studio background, so the first direction for me will be, I want to do Control-Shift-B. That's how I build, right? So it's actually going to be the same shortcut key in VS Code. So on Mac, it's going to be Command-Shift-B, or if you want to go there to tasks, there's going to be a Run Build Task menu there. So if I click on that now, it's going to tell me that no build task found. Press config build task to define one. So basically, I need to config that first. So VS Code ships with a few task runners. There's MS Build and a couple of other things, but really for what we need now is to run any arbitrary external command. So I'm gonna click on others. So VS Code creates a tasks.json file. This is the default things. Really, there's only a few things you need to change here for VS Code to be able to know how to build. So first of all, I'm gonna give task name to just name it build. And this is the key here, which is a command property. This is where you tell VS Code what external commands you want to run. In this case, I'm just going to do GCC. I'm going to do -G. This is really important if you want to do debugging later on. This gives you the symbols. And I'm going to do calculator.cpp file. And output, I just give it a name. That's all I need to do, really, to configure the build task. But I could do one more thing, because this, so far, VS Code knows this is a task. This is the command I'm going to run. But it doesn't know this is a build task. So what we could do is to say, give it a group, and let VS know this is a build task. And this is my default build task. The reason I want to set up this, just so I can use Command-Shift-B to build as a shortcut key. Much easier. So if I want to do that, or I can come here to say run my build task. That's the same thing. Build. Let's see this. Okay, it's running. It's kind of a little small, but this is actually my command ran in VS Code. And this is the result I'm getting back from the compiler that says there's a warning. Because VS Code doesn't know this compiler, so it doesn't know what to do with this output. So it comes back as just text in your output window. If you switch back to the problems window, you got nothing here. The problems window is like equivalent of error list in Visual Studio. Wouldn't it be nice if we could just go click on an error here, which would take us to the code? So actually, VS Code supports this by this property here called the problem matcher. What this is basically you have a few definitions that's defined via regular expressions, just so VS Code knows what to do with the output of your command. So we actually ship a default one for GCC. So you don't actually have to go define the regex yourself, but you can just use this default one. So now if we do run again, of course I'm getting the same warning. But now if I switch back, I'm actually getting the warnings and could be errors in the list. Now if I double click, it actually takes me to the code. Of course, this is about what the problem was, because it's because I have the switch branch, which may not be returning anything. So for now, I'm just going to make my compiler happy by doing this. If I do this again, it's going to compile just fine, and my problem goes away. All right, we're good. Now we have our file compiled, and I have a program I can actually run. Let's try that in the command window. So it's CppCon, and I have my calculator, run it. Oh, not found. Oh yeah, I have to do that. Keep forgetting when I switch back and forth between the machines. All right, so now we got our app running. It says I should put in numbers, so let's do 2 plus 3. Who would expect my code would just work? The code I typed on stage would just work. You guys, anyone bet it's working? No?
Number and then
Oh, you guys are better than a debugger. Really? Really? Because I was going to set up the debugger to figure out what the problem was. All right. Pretend you didn't know, okay? But really, I want to show how you can set up the debugger really fast in VS Code. So now if I want to come back to start debugging, so either I can go to the menu or I can switch over to this tab here. So you have the arrow that will launch the debugger. But before I do that, I need to set up configurations. Currently, there's nothing. I can click on that, which is asking me which environment I want to choose. So in VS Code, we support, on Mac and Linux, we support GDB and LLDB as your debugger. On Windows, you actually have the choice of MS Visual Studio Debugger or the GDB debugger. So in here, I'm just going to pick C++, GDB, LLDB. And similar to the tasks.json file, there's another JSON file that's created called launch.json. That's what you need to define for the debugger to work. So again, it comes with a template, and there are very few things I need to configure here. Really, the only thing that matters for launch is the program you want to launch. So VS Code need to know the name of your program. So just going to do workspace/calculator. That's all I need to configure. Now I can come back to my code, set a breakpoint right here, and F5. I think that should just work. Oh, did I save? I need to save this. Okay, now breakpoint is hit, but we haven't put our input there yet. Do that. Okay, so it's right here. It's not going to hit because I'm missing a character. Okay, now it's back in the debugger. So even though it's a pretty basic debugger compared with the advanced features in VS, it's got the basic stuff going. You can, as you can tell, you can hit breakpoint. You can step into the code. I can run into the actual code that does the calculation and go through and realize I'm not getting the result I'm expecting because my operator apparently wasn't getting the plus sign I was giving it. So now if I go back to my code, I'm going to see the result is wrong and my y value seems to be right, but x right, but operator, it was the problem. And then realized I'm getting this wrong. Wait, so it should be like this. So now, since I've made a change to my code, what I need to do, which I often forget, is I need to review my code first before I launch it, right? And there have been many times where I just forgot to review it and then wondering why F5 didn't give me the right result. So to prevent me from making that mistake, I'm going to come back here in the launch.json file, and I'm going to tell VS Code that before you do launch, maybe you do the intelligence, do a pre-launch task first. And in my case, I'm just going to have it run my build task. So now if I save, now we got a true F5 experience as you would have in any other tools. All right, now here's number. All right, yes. What time is it? 15 minutes. Yes, I did it. Thank you, guys. Oh, had to set up a debugger on stage. Okay. All right, before I move off this machine, let me show you how we did the magic, how we did the IntelliSense. Now, by default, you don't have to worry about this because everything is done behind the scene. But if you want to customize or if you're curious, this is what you could do. Do Command P, which is going to bring up the command palette in VS Code. This is where you can type in any command. So what I want to do is to type in CppCon edit configurations. This is the one you want to look at. This actually generates another JSON file, many JSON files, but I promise this is the last one. So we only have 3. That's the 3 you need to remember. This one is for IntelliSense. So as you know, the IntelliSense engine which is the one we're using right now, is a compiler-based engine. So it needs to know where we could find your headers. We need to know your include path. And this is where we do the magic, is we have the default for each OS. So for this one, which is Mac, this is the number, these 6 numbers of include path is where we look for. In this particular case, it's IO stream, which happened to be here. And the reason I got these 3 paths is because I have Xcode installed on this machine, so we do a detection. If you have Xcode, we have additional places where we look for those files. But if not, it's just going to be local include. So we also, by default, include the workspace root. So anything you put in there, we will find. So in this particular case, it's a really simple app, so I didn't need to customize these settings. But we're going to see how we can customize these in the next demo when I switch back to Windows. Okay, so that's that. And one more thing I want to show you before I move off this machine is the source code control integration. So we have our app running on this local machine. Everything is good. And now I wanted to put this under source control system. So VS Code actually has Git integration already built in. You don't have to do anything here. Coming here, you can do initialize repository, which is going to ask me for the path, which is the current path I'm in. Automatically, it finds all the changes I've made in this folder, and then I can decide which files I want to under the source code control. I can say stage all changes, and then maybe remove the ones I don't need back. Here, you type a check-in message. I don't have the machine connected, but if you had, just do this click. You're going to have everything checking to your Git under the Git control. You can also have VS Code connect to your repo on GitHub directly, and then you can publish all your changes directly to the remote repo as well. Now, the good thing about having the code under the source code control is now if I make more changes to it, real simple, you're going to start seeing these changes reflected in here in the VS Code UI. Now, I made some changes on this CPP file. Now I can right-click and say Open Changes. This is going to open a side-by-side view to diff the changes. Really simple, but you can pretty much just do everything, complete your code, build, debug, checking the code into source code control system, all from within VS Code. Okay, so let's go back now. Okay, so that was the first demo, and I did show you this one more thing, just to remind myself, I don't forget about Git integration. Okay, now let's try a different machine, Windows here, and we're gonna look at a more complex program, because you might say the calculator is too simple, too easy, and how are we gonna deal with a much larger project? And a lot of times you might be dealing with code base that you didn't write, like some other people's code base, and you might be getting stuff off GitHub and just want to read the code or make some changes. And you can actually do all that in Visual Studio Code with the help of IntelliSense and code browsing features. So what I have here is I already have a folder open. This is a project on GitHub, which I can show you real quick. It's called WX Form Builder. It's a pretty sizable project. It basically is a designer-based tool for you to help you design widgets or forms, and then it can automatically generate all kinds of code, C++, PHP. So it's a pretty complex code base. So if you look at all these source codes, it's got multiple folders, lots of CPP and header files in here, and in here this deals with all the designer stuff, so there's a lot more stuff in here. And utilities, lots of files. And here's a main GUI CPP file. Without really knowing much about this code base, I'm just gonna go and open a CPP file right here. Okay, so here's what you usually get when you open a project that you really don't know. is, hey, now I'm getting all these squiggles, what I'm gonna do? Because as I said, we really need, the IntelliSense engine really need to know where to find these headers. And by default, we show you a bunch of green squiggles. Has anyone seen these green squiggles in your code base somewhere in VS Code? So what do you guys do? What would you do when you see these green squiggles?
That's when I open it up in Visual Studio.
That's when you open in Visual Studio, when you have the option. But if you're on Mac and Linux, you don't. So let me show you some techniques. Actually, some of the latest features that we developed that could hopefully help to make that easy, because we know it's a pain to have to go through each header file and then find out where they are and add them manually, each one to the include path. So let me do this as well, which is we also show these problems in the problems window where you can see what files we're missing. In this particular case, the first file I'm missing is model/types.h, which is a direct reference from this file. So if you hover over this line, this squiggle, it's going to say there are include errors detected. Please update your include path. That's when you need to manually add all the include path. Remember that JSON file I showed you? That's where you add your include path. But the second half of the message basically says the IntelliSense features for this translation unit will be provided by the tag parser. So what is a tag parser? Tag parser is basically a fuzzy parser that we use to assist with the IntelliSense features. So it does not validate or recognize the full C++ syntax. It basically simply matches an input stream of tokens with some patterns. It does not know about types other than the built-in types. It does not have the full-time context of macros. Its scope, its translation unit is strictly within single files, meaning it does not follow through your pound includes. It does not have knowledge of that. But regardless of all those restrictions, it is super fast. So it can run pretty fast on large code bases. That's why we use that to assist our IntelliSense experience. But right now, this is saying the true compiler-based IntelliSense engine is getting errors. So everything here, all the IntelliSense experience you're getting here is provided by tag parser, because tag parser has more knowledge, even though it's fuzzy, it's not super accurate, but it actually runs fast and has some knowledge of your code. So here's, I will give you an example of what I meant by fuzzy results. So if I hover over here on this method, you'll see lots of possible matches. And in fact, this one here has a really, really long list, because arrays could be a member of vector, could be a tree, could be a string, could be a list. The tag parser doesn't know where it comes from because it does not know of any types. If I type in here to get my parameter hints, it's going to circle through all these different signatures. But in some cases, the tag parser would be doing a good job when there's no ambiguity in the symbols. So in some cases, you can actually get pretty good result by hovering over. So that's how the tag parser works, and the kind of experience you're getting by default is what these green squiggles indicate. But we really, really want to get the compiler-based IntelliSense working, because now we can get much more accurate results. When you type code, when you hover over, you know exactly which method you're looking at. So here's the new thing we added. And the bits might not be out now, but you will be today. So if you click on those green squiggles, you should see a light bulb on the left side. And that gives you a number of options. So if you guys are using the latest C++ extension before this one, you should already have seen these two options. But this is the new thing. is we're giving you suggestions where you might be able to find those headers. So if I click on that, what happens is if I go over to VS Code and go to that JSON file, under Windows, here's my include path. So what just happened was we automatically added the suggested path to include path. So you don't have to go through that manually. So that's great. Now let's come back to this file. Of course, I'm still getting squiggles because, there are multiple headers I need. And this time, it's actually not types.header.h. If you look at this in the problems window, they're saying we cannot open this wx string.h file, which is not a direct include, but it is a dependency of my direct include. So we are giving you more information about which file we're looking at, we're looking for. So you need to basically give us the this string and this string.h, where that file is, right? Now what I'm going to do is I have to probably go back to my File Explorer and start searching here, right? To find where the header is. That could be a really tedious task, and I really don't want to do that on stage, especially. So what I'm going to do is a new thing we added because of these suggestions that we populate, the way we populate that. Let me do that first, and then I'll explain to you what we're doing. So I'm going to copy over these 3 includes, which has the basic MinGW include and some special things. This is also MinGW, but some special things that this project is using. But I don't know all the subdirectories. All I know is all these root folders seem to have lots of stuff in there. But because of so many deep subdirectories inside, I'm just not going to go through that. But I'm going to have my lovely tag parser do the work, because the tag parser is a tireless hard worker that's going to go through everything in this folder. So in addition to the include path, what we have here in the JSON file is a browse path. I'm just going to do that first. Save it and let it do the work. You can see it's on fire. It's on fire. So we need to wait for that to finish. But essentially what we do is the tag parser is going to search through everything in those folders. It does it recursively, so it's going to search through all the subfolders. So the difference between the compiler-based engine and tag parser is tag parser does it recursively, but the IntelliSense engine does not. IntelliSense basically takes whatever include path you would have passed to the real compiler, so it has to be exact path where you can find those headers. But tag parser doesn't care. It's going to just go and look for everything in those whole folder. It's going to store all those information in a database, so it can look up really, really fast. That's how we use these. We are able to use information that's searched by the tag parser to populate these suggestions. So now if we come back here, we get more suggestions. Yay, this is a subfolder under the include path that I just pointed to, right? Now, instead of us having to search through, tag parser does the work, say, hey, we find some possibilities. Now, in this case, I was actually able to solve all those 3 green squiggles. Now, we only have two left. Yay, big progress. Now, once you do the change, do an update to the include path, the tag parser is going to keep working. It's really, really hard worker. Now, if I come back here, now we're getting some other IntelliSense results. I'll just add that one. So that goes away. Oh, there's only one coming back. Getting so close. This one is getting something. Oh, okay. More suggestions. For this particular one I'm missing, which is wx/setup.h file. So this is where the fuzzy result matters, is because tag parser doesn't really know. It has multiple choices. That's why we don't do everything for you automatically. But instead we provide these options to you, so you can tell us which one is the one you want to pick. So in this case, I'm going to pick this one. And of course, even if you pick the wrong one, you can always come back to the JSON file to modify manually. But the idea is really about, hey, let's help out here. Let the tag parser do the work instead. And all you have to do is to do multiple clicks on these light bulbs. Now we have some more. Does it go away? No. I might need to do that some more time. Oh, that's another challenge to do on stage, is to get rid of the squiggles. See how hard that is. It keeps coming back. Okay, how many people bet this time will work? Yes? No. More squiggles. So I'm done here. I'm not gonna try to resolve this on stage. That's too hard. But what I'm gonna do is to show you another thing. So there might be cases where you just can't locate the headers, like either the ones that you currently don't care about, or you just can't locate them at the moment. So the question is, at this stage, I've tried really hard to get rid of the screen squiggles, but if I really want to use the compiler-based IntelliSense, can I do that? So yes, you can. Here's the option you want to use. Is to go back to Lightbulb and say force semantic IntelliSense. What this does is it forces our IntelliSense to use the compiler-based IntelliSense and not using the tag parser to provide the IntelliSense results. So of course we're getting the red squiggle instead. That's an indication that you're using the compiler-based IntelliSense engine. Of course, that might be something you want to solve eventually, because that's going to be a build error. But the good thing about enabling the compiler-based IntelliSense is now actually you're getting real squiggles that reveals real problems in the code. Just to be clear, this is not a bug in this project. That's just a bug that I inserted here just so I can show you the squiggle, but it's not a problem with the project. So first of all, we get this squiggle that's telling us I'm not using this, not calling this function right because I'm not matching any of the argument lists. Now, if I do, remember we're getting lots of results before, like 10 or so, when we circle through the parameter hints. Now I'm only getting one. I'm getting two, because our IntelliSense engine, the compiler-based one, is really accurate. It knows exactly which function this comes from. So now I can type in. As I type, I actually get autocomplete as well. As I move over, it moves over to the second parameter. Okay, fix that. Oops. Switching back from Mac, clicking on the wrong keys. Okay, so that squiggle goes away. That's awesome. So we can actually leverage the red squiggles to fix real issues in the code. And basically what we do, so the default experience coming with the C++ extension, eventually, we are still experimenting these features, but eventually the idea is we're going to turn on the compiler-based engine as the default. If it runs into any issues, like any include errors that you see earlier, we're going to automatically fall back to tag parser to provide the results. So you still get fuzzy results, but you are not buried in like tons of red squiggles all over the place. That is why we had this automatic fallback mechanism in place. So I would definitely recommend everyone to use the engine, the compiler-based one, as the default, because you don't have to worry about squiggles all over the place, because we'll always fall back. So, but as soon as you tell us all the include path, as soon as it's configured correctly, we're going to automatically switch back to the compiler-based one, so you get the better results. So you don't ever have to worry about that setting, really. Other things I want to show you is if you're reading a large code base, you want to navigate through different files. We actually have built-in code browsing features. Right now, all these code browsing features are provided by the tag parser. So we are working on getting them to use the new IntelliSense compiler-based engine as well. But we're still in the process of doing that. But just to show you real quick, right now, as of now, this is experience you can get. So if I click on any function, I can go to definition, of course, or I can hold the control key to click. That takes me to the CPP file. From here, we can do a switch header source. That's going to take me to the header file. Of course, I can always just go through the declaration directly. I can do a go-to, which takes me to a different file, or I can do a peek, which brings in the definition into an embedded window, so I don't lose the context of my current file. So those are a couple of features. Other things we can do is to search for symbols really fast. So I showed you this command palette earlier. So if you go here and type in @ it's gonna give me populate a list of all the symbols. I can type in, I can do set list. It's just gonna take me right here. And we could also navigate through to different files. That's really easy to do as well. So you do Control P and you just start typing the name of the file. So in this case, I know there's a main GUI CPP file and just goes over there. So at this point, you can pretty much just use the keyboard for these quick navigations. And in here, I can do Control P, and if I do colon, this allows me to type in a line number. So I can do 241, which takes me to this line directly. Now in here, if you want to do some more editing here, one of the things you might want to do is if you have similar things in multiple lines and you want to do edit in multiple lines at the same time, you can actually do that in VS Code real quick with just keyboard. You want to hold Control and Alt and move your up and down arrow. Now I have multiple lines selected. I can select them all together. I can start type. I even get the IntelliSense as I type. But that's really, really convenient as you if you want to do multi-line editing. Okay, lots of the editing and code browsing features. Now let's talk about build a little bit. So early on, we built a really simple CPP file with just GCC command. This project is a lot more complicated. So it is actually set up to build with make. If I go in here, go to this folder, gmake, it's got a lot of the make files already generated. So what we want to do with this project is we want to build with make. You can absolutely do that in VS Code because we can run any external commands. You can do whatever you want. So I'm going to come over here. This is my tasks.json file. We're familiar with this. This is the command. Last time we just simply passing G++. This time I'm calling a batch file that I created. You can do anything there. So the batch file I have is really, really simple. It basically goes into the build folder and say, make me a debug build. And that's all I need to do. And of course, I can still do Control-Shift-B to build my project. Now it's gonna pick up the change I made in that CPP file when I fix the argument list. And it's gonna link. In a sec, we are gonna have our app build. All right, it's done. So that's building in VS Code with a more complex project system. And last but not least, we can still debug this app. This is an exe file. So if we go to launch.json file, and let me show you real quick. So in the last demo, I showed you how to do launch. Basically, you just need to pass in this parameter, the program name. Basically, that's all you need to do as well. So last time we debug with LDB, and this one I'm debugging with GDB. Very, very similar. All it needs is where we can find this program, which is this exe file right there. Now let me switch back to to my code. Let me show you something real quick. Just typing this file, because I know there's something interesting here. So in the CppCG file, it's actually doing code generation. As I mentioned, this is a form builder, which then generates a CPP file or lots of other languages file. This is where that happens. I know there's a function in here that actually takes the property of those controls on the designer and turn those values into the code. let's say I really want to debug this, but I'm so lazy that I don't even want to set a breakpoint. But I'm gonna come back here to the breakpoint. Last time we simply just clicked to get the breakpoint set, but here I can actually type in the function name to let VS Code find our breakpoint right there by looking at the function name. So now I should be able to launch the XE that I just built. Right there. There's our designer. Okay, let me add a form real quick and switch over to generate some CPP code. Yay, that's our breakpoint by function name. Of course, I can do the normal things. And other things I want to mention real quick here is this watch window. Of course, you can look at the local variables, but the watch window lets you to do expressions as well. We'll evaluate those. So in here, let's see, the type is PT text. So when I have this expression here, it's going to tell me it's false. Other thing I want to mention is all these threads. Not only you can see how many threads are there, but also you can click on each frame to look at each frame in here. So it's going to be really useful when you do multi-threading debugging. The other feature I want to show you real quick in the debugger is if I want to say, oh, this is a long switch statement. Oh, really, really long. So if I want to just skip all that and say, hey, debugger, just run here, because I don't want to look at everything in between. I can say run to cursor, and they're just going to go wrong. Of course, in this particular case, it circles back, but you can basically have the debugger run anywhere you want. Okay, so last but not least, when the debugging, when we are in the middle of debugging, you can actually interact with the debugger using the debug console window. One of the things we get asked pretty often is, hey, does VS Code debugger support viewing what's in the registers? And we don't actually have a window for that. We don't have a assembly window for that. But you can actually get the same information by just come here and do this command. -xe info registers. It's going to show you what's in the registers, what registers are being used. Basically, you can type in any GDB or LDB commands in the debug console if you want more information. Of course, you want to be careful because you're interacting with the debugger at the same time as it's breaking, so it might cause some problems with that. But viewing registers is definitely doable. No problem with that. Okay, so we're running short on time. Let me just move quickly over on these things. So pretty much just summary of what I just showed you earlier in the demo. I have lots of editing features, IntelliSense, code browsing, code formatting. We have 2 IntelliSense engines. One is compiler-based. It's definitely recommended with a red heart. And there's a tag parser-based one, which gives you fuzzy but quick results, and how you can switch between them. You can always switch, tell us which one to use. There's debugging, where you can, by defining a task JSON file, you can pretty much run any external tasks, which means you can build your projects with any build systems. We have built-in support for MS Build. You can, of course, build with Make, which I showed you. If you have CMake projects, we actually have an extension in the marketplace. This is called CMake Tools extension for VS Code. This is created by Vector Boo. He did a really good job getting the CMake experience in VS Code in there, so you can build with CMake projects with very minimal efforts in VS Code. External tasks, which means you can do anything else beyond debugging as well. You can do maybe packaging, testing, deploying. There's problem matcher and the integrated terminal I showed you, and a bunch of debugging features. Now, let me do the last demo real quick. That how you can customize VS Code to be your editor. Because I showed you how easily you can get things up running. I showed you the richness of the features across editing, building, debugging. Now you have, but you might still have one concern in the back of your mind, which is, if I'm coming from another tool, I'm already used to the colors or whatever setting or the key bindings over there, it's going to be a deep learning curve for me to pick up a new tool. Now, here's good news is VS Code is fully customizable. So first thing I want to show you is go to Preferences. These are the settings. Tons of settings in here that you can customize. For me, all I did was I changed font size for the demo, but that's how you find it. You do font. This is the default. The way it works is you have to click on Edit and replacing settings. It's going to copy over the setting to your side of the setting. This is everything you are customizing, and you change the value to whatever you want. And you can do that per workspace or per user, so it applies to all of your projects. Lots of colors you can customize. There are different color themes in here that you can use. Oh, actually, there's a quick way to get to the colors. Color theme. This is the default, but if you want to do high contrast, I actually like this one. Oh, this is the Visual Studio Lite. I actually like this one. Looks pretty nice. This might be too much. But the idea is, hey, we have a built-in lots of themes, and you can install additional themes. But if that's not good enough, you can come here and say, I want to totally customize all the colors to what I want. And there's tons of stuff in there. If you do let their IntelliSense do the work, tons of stuff in there. You can customize pretty much everything to what you want. And anything you customize here is going to override the default theme, what's in the default theme. Okay, so that's the look and feel. But if you ask about the key bindings, here is how you can customize all the keyboard shortcuts, every single one of them. If that's too much work, there's good news. If you're coming from other popular tools, and come here to find an extension that is designed to do the key mapping for you between the other tool and the VS Code. So I don't have the network connected, but if you do, here's what you're going to have. You have key mappings built in for all these tools. I'm not going to name them, but if you see anything missing that you would like to have, let us know. Last thing I'll show you. I thought it was a pretty cool thing is there's a Zen mode in VS Code. If I do that, everything else goes away. See, I'm just coding. Right here. Oh, no, I don't want to save that. Okay, so there we go. That's all you have. The Zen mode. Everything is peaceful. Okay, so a few quick things. As I said, you can fully customize VS Code to be your editor. Just to summarize what we covered today, a lot of stuff for with Visual Studio Code and the C++ extension. VS Code could be a really powerful C and C++ development environment, and it runs everywhere cross-platform. So you got a fast, lightweight tool that's free, open source, runs everywhere, customizable, extensible. There's lots of extensions in the marketplace today already, but if you find anything that's missing, it's really convenient to just write your own extension as well. And Git integration, I showed you a little bit. And on the C++ side, what we are adding to the experience is IntelliSense, code browsing, code formatting, and of course you can build and run with external tasks, and we got debugging functionality all built in as well. So everything can be done in that one UI. All right, I think that's my, one last minute, perfect, on time. Okay, call to action. After the session, if you haven't already, go download Visual Studio Code from here. This is where you can get a stable build. Or get VS Code Insider build. This is absolutely the cutting edge, latest editor. This is basically the daily build that we use internally for developing VS Code. So you're getting the exact same build our developers are using. We, as extension, we sometimes would experiment new features with the insider build first. So you're not only getting the latest from VS Code itself, you're also getting the latest from the C++ extension. You don't have to install both. You just need one. But of course, if you want to, they run side by side just fine. Just get either one of those. Get the C++ extension. This is where you can get them to install from Marketplace. Or you can just install from within VS Code, like I showed you. Click on the extension tab, type in C++, find the one that comes from Microsoft, and click install. That's all. More links down there to give us feedback and suggestions. Last but not least, follow us to get the latest news. We publish on Visual C++ team blog. Every time we ship something new, we're going to talk about it there. And follow us on Twitter. We also publish tweets there whenever we have news. And that's all I have. I think I'm running right on time. But I'm happy to take any questions after the session. But I want to thank you so much for spending the time here. Really wonderful audience. Thank you so much. And let me know if you have any questions. Thank you.